Today we are solving chemistry chapter wise paper 1, and the topic is states of matter. Okay, those of you who have the chapter wise question paper, you can find this on the very second or third page, I guess. And if you feel like I'm going a little too fast, then you can pause the video and complete your answers and take your time with it. So the first question we have here is basically where we have to join the lines connecting the terms. So let's see, if ice turns into water, that is called melting, because ice is a solid and water is a liquid. Solid carbon dioxide turning into gas, that is called sublimation, because the process is solid to gas, and the solid is stirred to be into the solvent, that is dissolving. Let's move on to part B. In part B, a student has two solids, X and Y. One of the solids is a pure substance and the other is a mixture. Describe how the student could identify which solid is pure and which is a mixture by measuring physical properties of each solid. Now, as they're saying physical properties, that means we cannot mention any kind of chemical substances in the whole process. We have to measure physical properties such as melting point, boiling point, density, all these stuff. So let's go with the melting point approach, because if we see that the melting point of a substance, of a pure substance, always remains constant, and when a substance is melting, it melts over a constant temperature. During melting, the temperature of the substance remains constant throughout. But if an impure substance is uh, being melted, first of all, the temperature will be a range of temperatures. The temperature at which it will melt will be a range of temperatures, which means, let's say that the melting process started somewhat at 80 degrees and it will continue till like 120 degrees or 110 degrees or something like that. This is the range of temperature. But on the other hand, let's say some substance dissolves at 60 degrees, but it will melt only at 60 degree, and after the whole melting process is complete and it has become liquid, that is when the temperature will rise to 61 degrees. Before that, the temperature will not change for a pure substance. So we have to keep that in mind. In the next one, we have to state the initial and the final states of these changes. So for melting, they have already mentioned it that it was solid and liquid. And now, if you look at the second option, which is sublimation, so for sublimation, the sublimation process is from solid to gas. And for condensation, it can be either gas to liquid or gas to solid as well. But we mostly prefer gas to liquid because as solid is not mentioned, and when gas is condensed, for most of the situations, it turns gas to liquid. And then we have evaporation, where the liquid is turning into gas. My mistake. Not liquid gas, liquid is turning into gas. Now, we have the question number B here, where they are stating that particles in a solid are closely packed, arranged in a regular pattern, and vibrates about a fixed position. Describe the arrangement and movement of the particles in a gas. Now, in a gas, as we know that the particles do not have any bonds between them. Now, take a look at it. It has 3 marks. That means we need 3 points. What should be the 3 points? The first point should be the pattern they are arranged in. Second point should be about the energy, and third point should be about the movement. Now, as we can see, they are irregularly arranged, that is the arrangement. The second one is the particles are far apart, that is the packing. And the movement and the energy, they have high speed and they can move in random directions. So that those are 3 points, right? The first point is the pack arrangement, the second point is the distance between them, and the third point is the speed and the random movement of them. Now, some might say that the high speed and random movement can be 2 points. Actually, no, because these 2 points are related together. The high speed is what creates the random movement. So the random movement part is basically a sub part of the high speed point. So this whole thing is one marking point. The far apart thing is one marking point, and irregular arrangement is another marking point. Now let's go to question number 3. From here we can see that melting in degree Celsius, boiling in degree Celsius. Now they are asking us which substance is a gas at 100 degrees Celsius. So for it to be gas at 100 degrees Celsius, it should have a boiling point which is lower than 100 degrees Celsius. Now in this part, which one has a boiling point lower than 100 degrees Celsius? That is 60, which points to W. That means my answer should be A, which is W. Now let's go to the next one. Which substance is a liquid for the largest range of temperature? Now let's find the largest range of temperature. Now what is the range of temperature? Basically we have the boiling point, we have the melting point, right? So if you take a calculator and we subtract these values from one another, we'll definitely get some new set of values. Okay, I'm not doing the whole thing, but like if you get confused about which one is larger range, you can do the calculation. But from here we can actually clearly see that 250 minus 660 should be the largest value among all of them. So this block should have the largest value of all of them. So the answer should be X or option B. Which substance is a liquid at 1000 degrees Celsius and a gas at 2000 degrees Celsius? That means if it's a liquid at 1000 degrees Celsius, I'm just pulling it up so we can see it from here. Now, as we can see that the temperatures are 1000 degrees Celsius and 2000 degrees Celsius. So, as it is a liquid, so my boiling point should lie between this range. So, where is my melting point, which is I need to find a melting point for which it is a liquid at 1000 degrees Celsius. Now I can see for all four like all three of these, it is a liquid at 1000 degrees Celsius, right? It should have melted at 1000 degrees Celsius. But if the boiling point is smaller than 2000 degrees Celsius, then it would have evaporated, or else it will not evaporate. If the boiling point is anywhere greater than 2000 degrees Celsius, then it will not evaporate. So the answer should be C. That is why. Why is that so? Because it has a melting point of 180, which means it is in liquid state at 1000 degrees Celsius. It has melted, but it is not boiled because the boiling temperature is 1300. And as 1330 is my boiling temperature, this is smaller than 2000. So at 2000 degrees Celsius, it should be a gas. I hope this part is pretty much clear. I think I can move on to number B. What type of bonding is in substance Y? Now, when something is taking so high energy to melt and so high energy to boil, it should have an ionic bonding. Okay, we will discuss about this in class also, but it should be an ionic bond. Now, suggest how the melting point of a pure substance changes when an impurity is added. Now, as we discussed earlier, when an impurity is present, the range of temperature over which the substance melts increases. So that's what we are going to write here for 1 mark. The impure substance will melt over a range of temperatures. That is the change that's going to come. Except for that, there is no other change in the melting point. The one change is that the impure substances will melt over a range of temperatures. Now, let's move on to question number 4. And question number 4 is about crystals of lead nitrate and potassium iodide, which are placed on two ends, on one on this end and the other on this end, on two ends of the container of water. Now, we need to write down the name of two processes that occurs to solid lead iodide. Okay, now one of them is dissolving, the other one is diffusion. Explain why solid lead iodide takes less time to form with the reaction is repeated using water at a higher temperature. I did not write this answer because I wanted to write it in front of you people. So first of all, it speaks of higher temperature. So how are we going to take this approach? We have to take this approach according to the kinetic theory of the particles. So at higher temperature, the particles will have more energy, and they'll move faster. Speeding up the reaction. Now, in this part, the two marking points is basically more energy and moving faster is 1 point. This is 1 point, and that is what will speed up the reaction is the second point or the connecting point. Now, this is what we needed, and we found all the things that we wanted to find. We needed two exact marking points, and we have them for the 2 mark answer. Now, the formula of lead nitrate is PbNO3 and bracket 2. So, give the number of different elements in lead nitrate. What most of you do is you people do not count it properly. So, let's count it together. Number of elements 1, 2, and 3. Now, what mistake do you guys do? As this is a 1 mark question, you people don't take it seriously. And instead of writing down the number of elements, you write down the number of atoms there are, or the number of atoms that are existing in one lead nitrate molecule. That is what creates the main problem. Now, give the charge on the lead nitrate PbNO3 2. So, give the charge on the lead ion. If we check out the periodic table, we will find out that the lead should have a charge of +2 because it is a metal and it has 2 electrons in its valence shell. As it has 2 electrons in its valence shell, it will donate those electrons and become positively charged. Okay, this is a balanced equation. Lead nitrate aqueous plus potassium iodide gives us lead iodide and potassium nitrate. Now, as I have had 2 nitrates here, I need to make this 2 nitrates. So I put a 2 over here, and I have 2 potassium over here, so I need to make this also a 2. I put a 2 over here, and now it is fully balanced. 1 lead, 1 lead, 2 iodide, 2 iodide, 2 potassium, 2 potassium, 2 nitrates, 2 nitrates. All of them are balanced on either side of the equation. So that's what makes a balanced equation. Now, which substance contains single atoms of one element? It's absolutely A, because these atoms are single, there is nothing joined to them, and they are looking the same, so it should be A. For part B, which substance is a compound? I'm sorry about the blurry image. Now, we can see that in this one, it is two atoms of the same element. In C, we can see that this is a different element, this is a different element, because they have different size and different shape. So, it is C. Which substance could have H2 molecules? Formula of H2, sorry, not H2 molecules, formula of H2. That should be B, right? Because that is a diatomic particle. Now, the diagram shows the particle in substance E. Give two reasons why substance E is a mixture. First of all, these two have different sizes, and secondly, there is no bonding between them. So, two different elements not chemically bonded. That is the reason why it is a mixture. I think this is pretty much easy for you guys, from solid to liquid melting, from liquid to gas evaporation, and from solid to gas sublimation. Now, this is an interesting question. The particles in gas are closely packed, arranged in a regular pattern, and vibrate in a fixed position. Oh, I'm very sorry. This is not an interesting question because I have solved this earlier as well. I have solved this once in the upper part. You can just rewind a little bit and you can find the answer to this one. It was in most probably question number 3 or question number 2, I guess. So I think I'll scroll down to question 7. Okay. In question 7, each circle represents a gas particle. Sorry, a molecule. Now we have the solid here, we have the liquid here. In the gas, we have to draw some particles that are away from one another, which have large gaps between them, so that drawing these will make sense. Now, read the question carefully. They have specifically mentioned 6 circles. Now, some people draw a lot of different circles and they do not concentrate on this part. As they have mentioned 6, there should only be 6. Even one extra circle will cost us marks. Now, which statement is correct about the movement or arrangement of the molecules in this substance? They move randomly in a liquid state. Yes, in a liquid state they can move freely and they can actually slip and slide over each other. So yeah, they move randomly in a liquid state. Which term is used for a solid changing to liquid? It should be melting. Some cold water is poured into a conical flask and a bunk is inserted. What is occurring in the flask? Now, they have mentioned cold water, which means the temperature is greater than that of the room temperature. Now, if the temperature is greater than that of room temperature, so it will eventually get hotter. So, one thing will be evaporation, and the second thing, as there is a bunk over here, it will evaporate and condense over here. So it should be B, evaporation and condensation. I think just the arrow moved out a little bit. This should have been B, that is evaporation and condensation. Fine. Let's move. Which formula represents a substance that is not present in the flask? Okay, why nitrogen liquid? Why not anything else? The reason is H2O, that's gas, that's steam. H2O liquid, that's water. Nitrogen gas exists in the air, but nitrogen liquid should be a different liquid. That's why it's D. Okay, the diagram shows arrangement of molecules of 3 states of water. Now, we were given the gas and the liquid state. We had to draw the solid state. Now, I drew the solid state like this, but like if you want, you can just draw 3 lines of it. Drawing this much will give you the whole mark. You don't need to draw the whole thing like I did. I did it because I felt like doing it, but you can just literally draw only 3 lines, and that is enough to get the 1 mark we have here. Fine. Okay, the row and table correct describes the arrangement of the movement of the particles of water in solid state. Regular, and vibrating. Which word describes water changing from liquid to solid? Freezing. This is solid to gas, sublimation. What are the two names of H2O? One is water vapor, the other one is steam. Fine. Let's go to question number 9. Okay, this one is interesting. This is the experiment between ammonia and hydrogen chloride. Now, if we take two cotton balls, soak one in ammonia and the other one in hydrogen chloride, and place them at two ends of a tube, eventually what we will see is these gases start to evaporate and they react with each other, forming a ring of ammonium chloride. Now, what is the process that is taking place in this whole thing? It's diffusion. Now, identify which gas is moving faster and give the reason. Now, to identify the movement of the gas, what we need to do is we will first need the formulas. And why do we need the formulas? NH3 and HCl. Now, NH3, N goes 14 plus H is 1, but there are 3 particles, so the mass is 17. On the other hand, for HCl, H goes as 1 plus a chlorine goes as 35.5. So the mass of hydrogen chloride is 36.5, which is nearly double that of ammonia. So that means ammonia is a lighter gas. A lighter gas will move faster. And how do we know that a lighter gas will move faster, but how do we know that ammonia has moved more? Because the ring that has formed is closer to the side of hydrogen chloride and further from ammonia. That means ammonia has traveled more path than hydrogen chloride has. Okay, now this question requires a little bit detailed thinking. The experiment was repeated at a higher temperature. Explain and state and explain how these changes would affect the time taken for the white ring to form. Now, I'm going to write this and I hope you guys will write this along with me. So, at a higher temperature, the particles will have more energy or greater energy. This was point 1. Point 2 is the particles will move faster and number of collisions will increase. There goes the second point. And third point is this means it will take less time for the ammonium chloride I'm not writing the whole thing, I'm just writing ammonium chloride solid to form. Now, in the exam, don't write like this. Write the full thing. Ammonium chloride solid. If you write like this, they are not going to give you the marks. Let's move on to the next one. Gas particles move at a speed of several hundred meters per second at room temperature. Suggest one reason why it took 5 minutes for the white ring to form. Now, particles move randomly. We know that. In a gas, particles move here and there randomly, so the number of collisions that is required for the reaction to happen takes time. Now, what is the number of collisions? Basically, these particles collide with one another. That's what causes the reaction. Now, for the white ring to form, a certain number of particles need to collide with one another to be able to produce the ring. So it takes time for that number of particles to collide and the ring to be produced. Okay. Number 10A, I think this is pretty much the same thing as we did earlier, solid to gas and liquid to solid and liquid to solid again. Fine. So which of these changes take place when solid iodine is heated and to form iodine gas? Because it's directly sublimation. Because solid iodine directly evaporates to form iodine gas. It does not melt. So the process is sublimation. Use words from the box to show the change. Now this is melting and this has to be boiling, this has to be condensation, this also has to be freezing, right? Okay, which statement best describes the movement of particles in gas? The particles move freely. This apparatus, they have asked us to find out the name of P, and the P is a thermometer. Solid Q melts at 140 degrees Celsius. Explain why water is not suitable solution, so suitable liquid to use in this experiment. Now, when something is melting at 140 degrees, which is way greater than 100 degrees, so if I use a solution that is 100 degrees melting point, the solution, 100 degrees boiling point, the solution will boil and evaporate away before the solid melts. So because it will boil at 100 degree and turn into gas before the solution even melts. Fine. Now, suggest why the liquid in the beaker needs to be stirred constantly. Okay, firstly, I'll explain it in the informal way, then we'll learn how to write it. Basically, when we are applying heat to any kind of liquid, the heat is being applied in one spot and it is not evenly spreading throughout the liquid. So we have to stir it to spread the heat evenly throughout the liquid so that all the parts of the liquid are at the same temperature. So now if we write it in a formal way, we can just try to keep the liquid at an even temperature, or we can also say to keep all parts of the liquid at the same temperature. That also works. Question number 12, the ammonia question again. Diffusion, we all know. As white ring forms closer to HCl, it shows ammonia has traveled further. Fine. I think there should be no problems regarding this, as we have already done this before. And in this one, okay, this part is something that I should explain. Teacher tests a sample of ammonium chloride solution. She uses this method to show that the sample contains ammonium ion. Add solution X. Now, when we will learn about the chemical tests part, we will learn that before performing some experiments, we have to add different kind of solutions like sodium hydroxide to get rid of unwanted gases that might be produced. In this case, the unwanted gas can be carbonate. So we will use solution X, which is sodium hydroxide. In this case, you can either write the symbol or you can write the whole thing. Both of them are correct. After adding this, then we warm the mixture and then something evaporates, right? So what is the gas given off? It should be ammonia gas. What should be the final color of the litmus when we hold the litmus in the gas that is evaporating? It should be blue because ammonia is basic in nature. Now, why did we exactly use the nitric acid? Okay, so here she uses this method to show that the sample contains chloride ions. So, for the test of chloride ions, we first add nitric acid. Why are we adding nitric acid? To get rid of any carbonates that are present in the solution, that might be present in the solution. So after adding nitric acid, we will add solution Y and see if a white precipitates form. What is solution Y? Solution Y has to be silver nitrate. Now, we can use nitric acid or we can use hydrochloric acid. As they have said nitric, it's fine, but we can also use HCl over here. But if we use HCl over there, we need to we will be adding chloride ion from outside. So that is a reason we are not using HCl in this equation, or else we could have. Now, the solution Y has to be silver nitrate. So eventually we will get silver chloride, which is a white precipitate, and this proves the presence of chloride ion. Now, if it was not a white precipitate and not it was maybe a yellow precipitate, that means it is iodine. So we will also learn the colors of precipitates that tell us what type of precipitates they are. Okay, a teacher demonstrated in a fume cupboard 2 experiments to show the movement of particles. Fine. Now here we first started with liquid bromine, and after a few minutes this whole thing spread out through the jar. So bromine has a darker color than air and bromine vapor diffuses upwards. These are the two explanations that are happening here. I understand the question is a bit blurry. Basically they want to us to tick two boxes which show what is happening in the diagram. So I'm very sorry for this blurriness, but that's what the question says. State whether the white ring appears at A, B or C. This is ammonia solution, this is hydrochloric acid. B is the midpoint. As ammonia is faster, it should travel more, and HCl is slower, it should travel less. So that means it should be producing the white ring at C. Explain your choice. That's exactly the thing. I am not writing this answer for you guys because I have explained this almost twice. I want you guys to write the answer once and show it to me. If any correction is needed, I'll help you with that, but I want you guys to give it a try. Let's jump to question 14. How many different elements are there in ammonium chloride? There is nitrogen, there is hydrogen, and there is chlorine. So there are 3. Identify 2 gases in mixture A. So what is mixture A? In mixture A, this is hydrochloric, sorry, my mistake. This is ammonium chloride and there is mixture A and there is white solid B. So ammonium chloride is one thing that is in the lower part. So there are 2 gases in mixture A, among which one should be ammonia gas, the other one should be hydrochloric acid, but in gas form. Only then they will react and produce this only that is the possibility, because ammonia chloride was heated to disintegrate it. So first thing first, if I have ammonia plus HCl, I get ammonium chloride. But if I take ammonium chloride and apply heat to it, it breaks down into ammonia and HCl again. So we will get ammonia gas and HCl gas out of this. Place a cross in the two boxes to identify the process that occurs in the test tube. One is definitely boiling, the other is decomposition, because the whole thing is getting decomposed into two parts. Question number 16. The crystal dissolves in water. That is what we are seeing here. It says observation. Observation means what we are seeing with our eyes. Now the beaker left until no further change. As the liquid was diffusing, all the liquid will turn purple eventually, because diffusion does not stop until all particles are at the same concentration gradient. Diffusion only stops when concentration gradient flattens out. Okay, basically when we have some substance here and we do not have anything here, it's empty, the concentration gradient is very high. As soon as this substance move here, the concentration gradient falls until it becomes flat. That means the number of items here and the number of items here are the same. What I mean to say is that when the concentration gradient stabilizes, that is when the diffusion stops. So if we leave it like that, all the liquid will turn purple. Which process causes this change in appearance? Definitely diffusion. The formula of potassium permanganate is KMnO4. How many different elements? Definitely potassium, manganese and oxygen. 3. Okay. And then there is this question number 16. Solid to liquid, solid to gas, liquid to solid. Okay, oh wait, I think I have copied the same thing twice. Okay, let's go to question number 17. Okay, sorry, there was something left. Yeah, I have solved this. Concentrated ammonia solution and hydrochloric acid are corrosive. So what should be our safety precautions? Safety goggles. If there was a second one, we could write wear gloves. But if we have to write only one, go with goggles. That is a safer option. Water to ice, steam to water, wax to liquid wax, iodine crystal to iodine vapor, sublimation. We all know all this. Say 2 things the student should do to make the salt dissolve quickly. One is to apply heat, the second is to stir. State. Now, state means it is somewhere here. We just have to state the answer. We do not have to explain or discuss anything or anything like that. State what the student should do next to separate the sand from the salt solution. Use a filter, or you can also write filtration, because filtration is the process. Describe how the student can obtain dry crystals. Okay, for this 4 marks, 4 points. First point, filter. I'm just writing the points, but you will have to write it in a composed way. I'm just writing the points. First thing, they have to filter it. Second thing, they have to, I think you should give it a thought. What should be the second point? First thing is, when we got it, we filtered it. We got the filtered water or something like that. So we will heat that until all water evaporates. After all water evaporates, let it rest and it will recrystallize. After recrystallization, let it dry. That's what we need to do. Now there are answers that are very well written in the book or in some sample papers. You can check out the answers from there, or if you feel any kind of If you feel like you're facing any kind of problem in answering these type of questions, you're most welcome to discuss with me in class, and I'll show you how to write the whole answer. But these are the marking points, and that's what I am going through. And that was the end of topic 1, states of matter, paper 1, question paper. And inshallah, next class we will try doing the paper 2 as well. Thank you so much.